If you can't do prevention, another alternative is to detect attacks and then respond to them. Okay? So the response, there's any number of things you might do to response. Like one possibility might be to reverse the effect of the attacker. Like, the attacker hacked my machine and deleted all my files, but I have a backup, so I restore from the backup. So now I've undone that. Or if it's a financial transaction, maybe I reverse the transaction, I undo it. That would be one example of a great response if you've detected. Or it might just be preventing future harm, like you can't change what's happened in the past, but you can block the attacker's account or go prosecute them or something like that. And the point here, I guess, is there's no point in detecting threats if you don't have a way to respond to them and react. When you ever have a detection mechanism, two fundamental metrics for how effective the detection mechanism is the false positive rate and the false negative rate. Okay, so what this has to do is with the errors that the detector makes. And there's two ways that a detector could make a mistake. The first kind of mistake is it sets off an alert when actually there is no attack. It calls up the cops, but your house isn't actually being robbed. So that's called a false positive. And the other way is it fails to notice that you're under attack. Okay, so it just doesn't detect the attack. So that's called a false negative. And we measure the rate at which those two occur. And that gives us some sense of the effectiveness of a detector. And both of those are bad. They both impose some cost. Obviously, if you have false negatives, then that's bad. That means hackers are breaching your security of your system, and the detector wasn't able to detect it, so you couldn't respond. So maybe you lose money because they hacked you. But maybe it's a little less obvious. But also false positives are bad because maybe it costs money to respond if you're paging a sysadmin in the middle of the night, you're paying them overtime hours and they're getting woken up. And even more so, if you are having a lot of false alerts, it tends to lead to a cry wolf phenomenon where if the sysadmin gets paged and they look into it oh, no, that wasn't an intrusion. They get paged and they look into it, that wasn't an intrusion either. And they look into it and they get paged again, and that was a false alarm too. After a while, the sysadmin is either going to start ignoring the pages or is going to disconnect it so they don't get woken up in the middle of the night. Another concept that you'll see in some systems is the use of defense in depth. So if I don't have a perfect defense, what I can potentially do is layer a couple of them. And the hope is that if the first one doesn't stop the attacker, then the second one will. Okay, so you saw this a lot in the medieval castles where they'd have, multiple levels of walls, and they'd have a wall and a moat, and they'd have a keep that they could retreat to when they were under attack. That was yet one more level, and so the attackers have to sort of breach all those defenses. Okay, so you hope that this gives you more security, especially if each individual defense is not perfect. Now, you can do some kind of analysis of defense in depth with multiple detectors. Let's say you have two detectors, and then you have a choice. If you have two detectors, you can decide to raise an alarm if either of them thinks something bad is going on, or you can raise an alarm if both of them think something bad is going on. And they basically lead to different trade-offs. So you can work out what the math is if you assume that two detectors are independent. They don't make correlated errors, which pretty dubious in practice. But what you find, basically, the bottom line is, if you raise alerts, if either detector does, then kind of makes sense. You'll detect more attacks. You reduce the false negative rate, but it increases the false positive rate. You're more likely to get false alerts. Because if either one of them makes a mistake and raises a false alert, then you'll end up with a false alert. And then alternatively, you could say, well, I'll only raise an alert if both of them think something bad is going on, and then that has the opposite trade-off. So this is typical when building detectors. Often there's some trade-off, and there's some tuning knob that you can control that allows you to trade off between the frequency of false positives and the frequency of false negatives. And the way you choose that is based on some kind of cost analysis.